All right, so let's take a look at these problems, verifying these identities. So we cannot treat this like an equality. We have to treat it like a question: is the left-hand side equal to the right-hand side? So we need to pick a side, and then algebraically, through simplify, substitute these identities to make it look like the other side. So there's a rule of thumbs that you can go by. In general, you want to start with a more complicated side. In this case, it's kind of a toss-up. I'm going to start with the left-hand side and convert the everything into sines and cosines, well, into cosines. So with the left-hand side, um, I know that I can rewrite secant as 1 over the cosine of x. And now, although I've taken something that's complicated and made it more complicated by making it a complex fraction, um, I'm going to multiply by the number 1, but I'm going to be clever in how I write the number 1. This denominator is cosine, and this denominator is cosine. So if I multiply by cosine over cosine, then I'll no longer have a complex a fraction within a fraction. So when you multiply fractions, it's much easier than addition and subtraction because you just multiply the numerators together and you multiply the denominators together. So in the numerator, when we take cosine of x, we multiply it times this binomial, both terms. So when you have 1 over cosine of x times the cosine of x, and then minus 1 times the cosine of x, what do we get? And then in the denominator, I've got 1 over cosine of x, that's that first term, times the cosine of x, and multiplication distributed over the subtraction. Multiplication also distributes over the addition. That's how both terms get multiplied by this cosine of x. Well, these are inverses of each other. Cosine divided by cosine is 1, because you can look at this cosine as cosine over 1, and when you multiply inverses, as long as you don't have a denominator of 0, the product is 1. So in the numerator, we have 1 minus cosine of x. In the denominator, we have 1 plus the cosine of x. That's what our right-hand side says. So we have shown that the left-hand side does equal the right-hand side, and that equal statement is that this is a true statement. These two expressions are equal to each other. All right, let's take a look at the next one. So I would argue that the left-hand side is more complicated than the right-hand side, not only because it's a fraction, but it has higher order terms. So let's start with the left-hand side, and let's factor this numerator. So when you have a sum of cubes, then that factors to the sine of x plus the cosine of x, that binomial, times the sine squared of x minus sine of x, cosine of x plus cosine squared of x. So our denominator now, you have to be careful when you're simplifying fractions. When you have multiplication, then these are factors, and common factors do cancel, but terms don't. So this sine of x plus cosine of x, that factor divided by this factor is equal to 1. All right. Now, the order that we do our addition is not important. So I'm going to rewrite this in a way that hopefully something will jump out at you. I've got sine squared of x plus cosine squared of x and then minus sine of x cosine of x. Oops. And that's all over 1 because we canceled that. Well, the reason that I wrote these two terms right next to each other is by our Pythagorean identity, sine squared of x plus cosine squared of x is 1. So we have 1 minus the sine of x times the cosine of x. And even if this multiplication was a different order, it's the same as the right-hand side. So we're done with this one. All right, so I would argue that the left-hand side is more complicated than the right-hand side. So as a rule of thumb, that's the one that we start with. And I don't see any identities that I could, known identities that I could substitute in. But I do see that on the left-hand side I have two terms. On the right-hand side I have one term. So if I get a common denominator, I can do this subtraction, and instead of having two fractions, I'll have a single fraction. So let's get a common denominator. So let's look at this first term, and the denominator that we want to shoot for is 1 minus sine of x times 1 plus sine of x. So we're going to multiply this first term by 1, but we're going to write the number 1 as 1 plus sine of x, because that's the factor that's missing in the denominator of this first term. Now we have subtraction, and this denominator is 1 plus sine of x. It's missing 1 minus sine of x. So that's how we'll write the number 1 for this term, is to write 1 minus sine of x over 1 minus sine of x. Alright, so that gets us a common denominator. It doesn't matter the order of multiplication, whether we write 1 minus sine first or 1 plus sine first. That's the denominator. And now that I have a common denominator, I can do this subtraction in the numerator. So here on the left-hand side, I have 1 plus the sine of x squared and 1 minus the sine of x squared. Alright, now I don't see any way to cancel. I'm going to have to multiply things out. So in the denominator, it may not look like it, but this is just a minus b times a plus b. So this multiplies to 1 squared minus sine squared of x. Now I have to be careful when I'm squaring things. Exponents don't distribute. I have to FOIL this previous, well, FOIL only works for binomial. I have to use the distributive property. When I square this, I get 1 plus 2 sine of x plus sine squared of x. And I have to be careful here with this subtraction that I'm subtracting the whole thing. I'm subtracting the product. So I need parentheses around this trinomial when I square it. So I've got 1 minus plus. Alright. So let's simplify this numerator. We have 1 minus 1, 1 minus 1, and that cancels. And we have 2 sine of x, and the double negative there, plus another 2 sine of x for 4 sine of x. And sine squared minus sine squared, those cancel. So the only thing I'm left with in the numerator now is 4 sine of x. 1 minus sine squared, by the Pythagorean identity, I can replace 1 minus sine squared of x with cosine squared of x. So, keep in mind what you're shooting for. Here's this 4. Well, I'm glad I have a 4 here, and I have a product, and I have sines and cosines. And if you look if you look at the quotient identity, tangent of x is the same as sine over cosine. So I'm going to take this cosine squared and I'm going to split it up into cosine times cosine. Okay. And if I take this single fraction and I split this up into four fractions where I'm multiplying these, remember it's the same thing because you multiply straight across the numerator and straight across the denominator. So I haven't changed this, but I can now write 4 divided by 1 is 4. Sine of x divided by cosine of x by the quotient identity is the tangent of x. And by my reciprocal identity, 1 divided by cosine of x is the secant of x. So I have the right-hand side. 4 times tangent of x times secant of x. That's what we were shooting for, so we're done with this. We've shown that the left-hand side is equal to the right-hand side. All right. So it's a toss-up here as to whether you want to call the left-hand side more complicated than the right-hand side. I would call the left-hand side more complicated simply because of the higher degree. It appears like I'm always picking the left-hand side, but that's just coincidence of how these have been written. All right, so let's look at this fourth. Remember that if you have a power to a power, you multiply exponents. So it could be to my advantage. I don't know if this is going to work out or not, but to think of this cosecant to the fourth power as cosecant squared of x, and that whole thing squared minus, and the same idea, cotangent squared of x squared. So I do have a cosecant squared and a cotangent squared, but that's, I have this. All right. Now I have my Pythagorean identities, and let's see what that could yield. The cosecant squared of x is the same thing as 1 plus cotangent squared of x. If you look at your reference sheet, you'll see that that is one of the Pythagorean identities. And, this guy is cosecant squared of x minus 1. Now, is it possible that when we square these out, because of this subtraction, that we're going to have these middle terms cancel and the ones cancel? Yeah, and it looks like that. So this looks promising. Sometimes you just have to try something, and if it doesn't work, you wad up the paper, throw it away, and start over again. So when we square this, remember exponents don't distribute. So I've got 2 cotangent squared plus cotangent. Boy, this is not going to work out, is it? Because how am I going to get rid of this cotangent? I'm getting that back again. You know what? Right here I've got cotangent of fourth. So what if we leave this one alone, cotangent to the fourth, like we had up here? Let's try this. So if I focus my attention on that cosecant squared and replace it with 1 plus cotangent squared, okay, when I square that out, then I have this minus cotangent fourth to the x. So I have 1 plus 2 cotangent squared of x. Now, what if I replace that 1? what if I know that cotangent squared of x plus 1 is equal to cosecant squared of x? Well, we can look at this, number 1, as cosecant squared of x minus cotangent squared of x from my Pythagorean identity. So this 1, I can replace it with cosecant squared of x minus cotangent squared of x. That's that 1, and then I have 2 here, and the negative 1 and positive 2, we've got it. We've got cosecant squared of x plus cotangent squared of x, and that is the right-hand side. Now, oftentimes, when you're doing these verifications of these trig identities, if you have something that's kind of long here, once you get it, sometimes you can look back and see if there were any shortcuts. If you can, ideally, the best verification is the shortest and most direct verification. So if there's some steps that you can eliminate or different substitutions that would make this shorter in length, that's usually a preferred solution. I don't see it really here, but it's just something I thought of to point out to you. Let's see, I would probably argue that the left-hand side is more complicated than the right-hand side, and I would start with it. And I would start by factoring the denominator here. So the numerator, let's leave it alone for a second. And the denominator, this trinomial, let's factor it to cosine of x times the cosine of x, and plus 2 and plus 1. Okay. Now, the sine squared of x by the Pythagorean identity is 1 minus cosine squared of x. So what made me think of that? Well, these are already cosine. If I can have everything in the same, and my right-hand side is cosine. So anytime that I can replace a sine with a cosine, or, in this case, sine squared with 1 minus cosine squared of x, it seems like a good idea, because we're trying to get rid of anything that's sine, because all we have left over here is cosine. Well, we can factor the numerator, because this numerator is really 1 squared minus cosine squared, a squared minus b squared. And we already know that a squared minus b squared factors to a plus b times a minus b, where a is playing the role of 1 and b is playing the role of cosine. So 1 minus cosine squared of x factors to 1 plus cosine of x times the 1 minus cosine of x. And things are looking fantastic now, because we're basically done. This cosine of x plus 1, the order of addition doesn't matter. 1 plus cosine of x is the same as cosine of x plus 1. And this is multiplication, so these are factors. And common factors can cancel. I can't cancel common terms in a fraction, but I can cancel common factors. So that leaves me with a numerator of 1 minus the cosine of x, and a denominator, the cosine of x plus 2 is the same, the order of addition. That we say that addition is commutative, that when you have a plus b, that's the same thing as b plus a, and that property is called the commutative property. And so this is the right-hand side. So we've shown it. Let's take a look at this next one. Again, what do you want to call the more complicated? Well, I would call the more complicated the binomial times a binomial. All right. So let's start with this left-hand side and simply multiply these together, because I really don't see what else to do. But but I do kind of see a little, what this tangent of x and cotangent of x, we have a rule of thumb that says whenever possible, try to write everything in terms of sines and cosines. So let's multiply this out, and then when we see tangent, we'll replace it with sine of x over cosine of x, and for cotangent of x, cosine of x divided by sine of x. We'll use those quotient identities from your reference sheet. So if we multiply this out, we've got the sine of x times the cosine of x, and then times the second term, the sine of x times the cotangent of x, and then minus the cosine of x times the tangent of x, and then a negative times the negative is positive, and tangent of x times the cotangent of x. Alright, so now everywhere we see cotangent, we'll replace it with cosine over sine, and tangent of x with sine of x over cosine of x. So this first term we leave alone. And the sine of x, maybe just for illustration purposes, we'll put it over 1, because this cotangent is cosine of x divided by sine of x. And it just makes it more obvious that this factor in the numerator cancels with that factor in the denominator. So the same thing happens here. Tangent of x is the sine of x over cosine of x. And these common factors in the numerator and denominator divide to 1. Well, these guys are reciprocals of each other. And when you multiply reciprocals, you get 1. That we can replace it with sine over cosine, or we can simply say, well, I know that since they're reciprocals, the tangent of x is the same thing as 1 over the cotangent. And you could, so there's multiple ways that you could illustrate that this last term, that product is equal to 1. Alright, so we have this first term, sine of x times the cosine of x, minus the cosine of x minus the sine of x plus 1. Alright, so we want to factor this, and we can factor this by grouping. If we look at the first two terms, here let's put a 1 here and a 1 here to also help us. If we look at these first two terms, cosine of x is common to both of those terms. I have a cosine here and a cosine here. So if I pull those cosines out, if I factor a cosine, and I'm just focusing my attention on these first two terms for right now. If I've pulled this cosine out, all I have left is the sine of x. And if I've pulled this cosine out, all I have left is minus 1. Now, sine of x minus 1, boy, I wish I had that over here. And I kind of do. What if I factor a negative 1 from each of these terms? What if I look at plus 1 as minus a negative 1? Okay, so I see that I have a negative 1 that's common to both of these terms. If I factor out that negative 1, what I have left in this term is the sine of x. And what I have left over here is just the 1. Okay, so now I have sine of x minus 1 and sine of x minus 1. And that's factored out, and what I have left in the first term is cosine of x minus 1. And that's the right-hand side, so we're done. Now, I just thought of something. I have seen students also do this factor by grouping in the form of a table, so maybe I should have illustrated that. Let's go back here right now and look at this. What if you didn't really like the way that I did this, which is sometimes common. what if I put, now, in a lot of times when we enter information in a table, we enter it diagonally. But here, what if we just go straight across left to right and then straight across left to right? What if we put the sine of x, cosine of x, and then minus cosine of x, and then minus the sine of x, and then plus 1. All right. So if we have a negative and a negative here, so what if we, negative 1 times the negative 1 is positive 1. And if we look across here, what divides both of those terms is cosine of x, and what divides both of these terms is sine of x. And you can see that we have sine of x minus 1 across the top and cosine of x minus 1 across on the side. So that could be another way that instead of this factor by grouping, that maybe, again, that you like seeing that distributive property in the form of a table. All right, so let's, in general, it's easier to condense something to a single term rather than to expand a single term into two terms. So I'm going to, even though this is a fraction, and some people may say the fraction is more complicated, I'm going to start with the left-hand side and reduce it, do this subtraction and get a single term for the right-hand side. So one of the rule of thumbs too is to write everything in terms of sines and cosines. The secant of x is 1 over the cosine of x. The tangent of x is sine of x over cosine of x. And then I've got times this sine of x, don't forget that sine of x, and I'll just put that over 1. Well, hey, this is kind of nice. We already have a common denominator. So in the numerator, we can do this operation of subtraction. And sine of x times sine of x, we abbreviate it sine squared of x. And by our Pythagorean identity, 1 minus sine squared is cosine squared. So you have two factors of cosine being divided by cosine. Hopefully it's extremely clear that cosine of x times cosine of x divided by cosine of x, that since this is multiplication, those common factors reduce. And cosine is the same thing. Cosine and secant are reciprocals of each other. So cosine of x is the same as 1 over secant of x. And that's the right-hand side. See, it would have been a little bit harder had we started 1 over secant. It would have been easy to view this as cosine, but it's a lot harder to look at cosine and recognize, hey, I can rewrite cosine as cosine squared over cosine of x. You can go in the reverse order if you start with the right-hand side through this series of equality and end up with the left-hand side. But some of the steps are just, when you're expanding, are just not as obvious as when you're condensing it. All right. Now, this is actually an identity that we have on our reference sheet, but they're wanting us to verify it, and it's pretty easy to do so with the Pythagorean identity. So let's start with the left-hand side. And let's replace cosine squared of theta with 1 minus sine squared of theta. And so that is the same as this. Well, then you're pretty much done, because now you subtract another sine squared of theta. And these two terms are like terms, so you write it as 1 minus 2 sine squared theta. So this one was much shorter than some of the others. Alright, so I hope that helps, and I'll talk to you later.